Right, so story time. We're going to start with a little bit of a story just to contextualize some of the work that I'm going to be talking about. And we have, and I know this is going to be, I'm going to ask you to stretch your imaginations. We're at a Women in Data Science conference, and I want you to imagine a woman who's a data analyst, for example, and she's been out of school for 3 years, and she's been working in a data analyst role. And she's had a terrible day at work. And so what happens when people have terrible days at work is that they, depending on how terrible it is, so this might be during her lunchtime if she's had a really bad day at work, or it could be when she gets home, she'll start looking for jobs. And so I wanted to sort of give these two examples of things that she would come across when looking for jobs, like the fact that job descriptions tend to be quite unstructured in terms of the data for a data analyst, and that two roles that could have the exact same title could be quite different in terms of what type of roles they are. So on the one hand, a role many of you would be familiar with, a research analyst, could be quite an entry-level role at a lot of different companies, including banks. And many of you who are in the finance sector probably know that a research analyst is a super duper senior role at a bank and various other research firms. And so the title and various other parts of the language make it very difficult for us to understand what type of role this is. And if this is difficult for someone who's a human being trying to understand which role to apply for and what's actually important in terms of job descriptions, it's actually really hard for computers to understand. And so the fundamental sort of question and the problem here is that jobs are actually very hard to analyze, they're very hard to categorize, it's very hard to extract important information from them. And that's actually my job, is sort of trying to understand the way that we use language and the way that we talk about skills and jobs, and how we can extract the important information from that. So I work at a software company, but I'm actually part of the I run the R&D. And we're sort of a little bit different compared to most software companies because we sort of not just invest in the software side of things, but because we're in the recruiting space, it's actually really important for us to know what happens, how people make decisions about jobs and documents and people in this process. So actually we do a lot of primary research, not just looking at what is a successful career document. And by career document, we mean things like job descriptions, which is what I'm going to be talking about mostly today, but also things like resumes. Is the structure or the content of certain types of resumes more effective than others? Those are sort of questions that my research group looks at. And secondly, on the decision science side of things, which I'm actually not going to talk about today, but is actually very critical to understanding the data science side of things, is how does a candidate decide which job to apply to, and how do we as evaluators, as hiring managers, as recruiters, make decisions about which candidates are more in tune with the requirements of the job, and how do we make decisions about which are the more important qualifications that are important in that process. And so our goal is to help companies make more fair and more efficient recruiting decisions, and we do this in part by some nudges that we do on the decision science side of things, which is backed by a lot of the data science side of things. But today I'm actually going to be talking about this point here, which is about what skills are increasingly important for different industries. That's actually very important for the work that we do, because we try and make sure that the jobs that people are asking for match the qualifications of the talent market and the labor pool that are there. So part of what we do is sort of try and forecast what we think are important skills and try and help in that process. And so that's where the genesis of the project that I'm going to be talking to you guys about is based. And this all all of the work that I do sort of becomes this beautiful piece of software that I had absolutely, nothing to do with the visualization. That's how I can call it so beautiful. And you can't see a lot of the bright colors and things like that here, but essentially companies type in job descriptions and we give them suggestions based on the skills and the language and the content of the job description. And we also try and guesstimate how much we think that sort of role is worth in terms of a salary. And the goal of that is to sort of really pare down job descriptions so that they actually represent what you can get from a candidate and that you have budget for. And so we don't have a lot of like a lot of job search processes, they go through this process and then they find out that the person who they want, is way too expensive for the role that they have. So to come back to the question, which is how have data science skills changed over time? And I want to take you through a couple of different approaches that you can use to answer this question. And what I want to do is highlight some of the things that we've seen in experimenting with these approaches as well. So one of the easiest ways to figure out how things have changed in texts over time is to do sort of manual feature extraction. So for those of you who are less familiar with what that means, it means sort of defining all of the different ways that, for example, a word like SQL, or an idea like SQL rather, so relational databases, MySQL, Postgres, all of the ways in which we can refer to that word and then define those and then extract them and say, every time that comes up, that's a 1 mark for SQL. And this is a very effective tool if you're able to define all of the different ways that these sorts of things can manifest. But the problem with an approach like this is you've already decided what you think is important because you have to define them, and it takes a lot of time and energy to sort of set up definitions of various areas. And so PhD can take it many different forms. It seems like a very simple thing, but you could talk about a doctorate, you could talk about PhD with lots of dots in various different places. And so that's really important. And something as simple as Python can actually be quite difficult because not every company talks about Python. They might be talking about Django. They could be talking about various other sort of broader infrastructural decisions that you make that imply Python to someone who knows. And so a computer doesn't know that, and you have to define it. The alternate approach is something like dynamic topic models, and this is something that a researcher called David Blay, who I'm going to come back to a little bit later, sort of developed in the early 2000s. And so it was very much, it's basically, it's a sort of somewhat unsupervised approach, so that's nice in comparison to manual feature extraction. And what it does is it sort of, every topic model has, every document can have multiple topic model, can be associated with multiple topics. And so this is just a time-wise difference. And what you can see, and apparently, and I'm not a physicist by any stretch of the imagination, but according to these sorts of things, it requires you to sort of get involved in the data and make decisions about it. And so you can see that there's like an argument for how there's, in the early 1880s, that's sort of associated with the terms that came out of that were associated with matter versus in the 2000s you've got more of a quantum association. Now to me as a layperson I can't tell that from those words that are up there or the associations with that, and so that's one of the things that's a problem with the dynamic topic modeling is because you again have to insert yourself in this process, that it gives you something but you have to sort of make some sense out of the definition. And the only other thing that I would say is that the problem with, especially to something like dynamic topic modeling is, and this is not something that I want to spend a lot of time with, is that there's semantic changes in words. So the word atom might be used in a very different context depending on what words come before it and what words come after it. And a model like this doesn't actually capture it. But the one thing that does capture it are these things called embeddings. Embeddings are, and I'm going to take this back a little bit and make it very simple, are a distributional mechanism of unsupervised sort of feature extraction. And essentially what they use is that they use the idea that you can understand a word by its context or the neighbors that it keeps. And so here's an example again. I'm using Python as an example. If we were aliens and we came to the Earth and we were sort of like, let's go through some job descriptions because that sounds like a lot of fun. And that was a joke, but anyway. And we want to know what Python is. And what we would do is we'd try and understand what these other words around Python meant to be able to understand what Python is. And so we know that like Python is very close to programming language and it keeps coming up close to programming language or programming. And so we would be able to infer that Python is likely something to do with programming. We likely have something to do with language, and we see that Java is quite close to it in many examples, and so that's again another example of the context helps you understand what that is. And so and this is a bastardization of all of this, of embeddings, but I think the critical thing is that there are a lot of different models for embeddings, and I've experimented with a lot of them, but what I want you to take away from this is essentially that they are a form of, there are many ways that you could sort of get to the point, but essentially you go from having a whole lot of vocabulary and billions of tokens, and this blue box here, if you can imagine, if this part vocabulary and what we reduce it to is in scale, this is sort of the distance between the East Coast and the West Coast of the US. So like we're talking about a massive reduction in dimensions. And that can happen through neural networks, and depends on the model. They all sort of use a different mechanism of doing that. And that's sort of the model that we're using. This sort of embedding model is essentially this representation here. But what you typically see when you look at embeddings and you look at papers in embeddings is you see this further 2D, this dimension reduction, and we see it in 2D. And so you can see that Python, again, from that previous example, is very close to object-oriented. It's programming, but it's a little further away from words like French and German and Japanese, if we were to sort of look at it in that context. And so we can understand certain things from the distance between these words from each other. And so these models have been really powerful in a lot of different areas. These are examples from the Stanford NLP project of their glove embedding. And what I love about this actually is that there's a lot of information in these 2D plots that sort of, I think, really belies the power of embeddings. And when they first came out, everyone was like, wow. So this is from the Google News, I think, corpus. And so you can see the relationship between companies on this left-hand side and the CEOs on the right-hand side. And what I think is really wild about this is Vodafone, Verizon, and Viacom are all media companies, and they're sort of clustering together a little further away from Exxon and Walmart. And all of the CEOs are sort of clustering very similarly. And so that was sort of very interesting to me, that it captures that sort of information within that, from that broader corpus. What's great is that you can also understand comparatives and superlatives. So the relationship between words, again, if you're an alien coming into the earth and trying to figure out what slowest was, you could probably do that through this sort of distributional representation. And probably the most powerful thing that embeddings were able to do that really took everyone's imagination was this idea that you could do word algebra. And so it was king minus man plus woman gives us queen, which is really extraordinary in terms of inferring information. And these models have been really useful, especially in terms of trying to map how languages sort of, like as in what is the equivalent word in another language. It's been used in a lot of analogous examples. But there are problems with these. And then the first and the most important model that's really important to think about when you're developing embeddings or using pre-trained embeddings is that whatever bias that's in your corpus is going to get reflected in the embeddings. And so this is an example, and I'm not sure if this is an actual true example because I haven't played with their specific embedding, but this idea, this was a title of the paper was "Man is to programmer as woman is to homemaker." And that is a problematic argument, but it's definitely something we see rife. So we're not talking about just, taking Reddit as a corpus. We're talking about our Google News corpuses are full of these sorts of, in fact, this is the Google News corpus was what was used for this. And so they do reflect cultural biases in corpora, and there are mechanisms and there are algorithms that people are trying to come up with to reduce the levels of biases within those. So we see the same thing also, or the same thing has been reported as well with African American names, for example, in these sorts of embeddings. And so there's been a lot of beautiful work being done to de-bias them. But one of the things and one of the problems with sort of trying to de-bias an embedding after the fact is you can only get so much, and if you're biased in one area, you can't really de-bias in a second area. And so you have to kind of pick which area, because then you start messing with the quality of the embedding. So what's beautiful about this process is that actually we have a lot of pre-trained embeddings and they facilitate fast prototyping. That's actually very important on the one hand in terms of if you want to get up this process really quickly, it's very easy, but then at the other hand, when you're using other people's embeddings, they might be biased. And so that's something to bear in mind depending on what you're actually trying to do. So this whole process of going from corpus generation, corpus processing, to generating a language model and tuning a language model used to take months. But now what you can do is use pre-trained embeddings from different sources, and they've been spent a lot of time trying to optimize this, and so you can get to this point and start getting into your final application overnight, which is something that was very unthought of for a long time ago. And the thing that I would say about these is when you're using these pre-trained models, and our experience has been, you definitely want to match the corpus that you're using to the one that's being tested on. So for example, if I was doing a project where I'm looking at sentiment analysis on social media, I'm not going to use the Wikipedia corpus because that tends to be quite unemotional for the most part, or at least the editors try and make it as unemotional as possible. And so it's not going to give you the sort of valency of the sentiment. The words that you want probably won't be there, and the way that they're going to be used is going to be different. Compared to something like Twitter, where you're going to get a lot more social media, like you're going to get a lot more sentiment analysis or sentiments in that. And so it's learning those sorts of processes. So again, matching the pre-trained embedding to the corpus that you're using it on is actually really critical, and it's really helpful to have sort of that overlap. And that's important because the vocabulary size sort of is determined. So there's going to be a lot of unknowns in your area. Then if there are words in your corpus that are really important that aren't in the embedding, and it's not going to be able to pick that up, then it's not going to be very helpful for you. And then the last thing I would say about these sorts of processes is that they have different vector lengths. And this is something I didn't talk a lot about before, but you can have a different level of dimensionality for the vectors, and that confers a different level of complexity. And sometimes, you know, if you're working on a mobile app, for example, you might not want a 300-dimensional embedding necessarily, because it takes longer to sort of process and respond to. And so what's nice is that quite a lot of these have got a lot of different dimensionality. But these help you fast to prototype really quickly, but in our process, when I'm looking at job descriptions, there's some real problems with using these embeddings. And the first is casing. For us, actually, IT is very different to it. And the problem with a lot of these sorts of processes and these embeddings is that they've all, many of them, not all of them, have made them all lowercase, all the words lowercase. And so it would be, would look the same as it in all of those contexts. And we lose a level of meaning because quite often you have things like stop words and things like that that extract very common terms. It is one of those common terms. The same thing with US and us, right? So if that's actually really important to you, those are two very easy examples of how casing can go wrong. Or if you have a lot of acronyms that you really need to be cased in a certain way, using a pre-trained embedding is probably not going to be the best for you, and definitely wasn't for us. In terms of out-of-vocabulary words and acronyms, it's actually really important if there are important words. It's very important if there are words in your corpus that you're looking at that are very important. And I keep saying important because it is really important. But if there are certain words that are critical, that they be able to be tracked to an embedding. So by that I mean, quite often. For us, when we're looking at job descriptions, there are certain technical terms that probably don't come up very often in the Google News, corpus, but actually are very important to us. And so we found that because they didn't come up, they came up as an unknown, and so it couldn't interpret those words, and that was a problem. And it does depend in terms of polysemy is words that have multiple meanings, and so sometimes that actually matters more for you. So, if you use the Google News corpus, for example, we would be emphasizing driving a car, meaning of the word drive rather than driving results. or in our case, it's actually very important to disambiguate chef, the job, because we also look at chef jobs versus chef, the language. And so there are mechanisms now and tools and algorithms and new ways of doing embeddings that take into account the sense of the word, or whether the word is a noun or an adjective, and that sort of side of things. And then the last part of this is words that have multiple, that have new meanings. So for us especially, front end is very different to front plus end. And so using a pre-trained embedding wasn't helpful for all of these reasons for us. And that might not be the case for everyone. These are just a couple of examples of what we found were highly problematic, and then it made it very difficult for us to use these. So we had to train our own. And so this is, again, just like how pre-trained embeddings have made life a lot easier, a lot of these tools make it really easy to pre-train your own. And so the stack that we use, or that I use, is Spacey, because I'm actually in the Python ecosystem. Spacey is sort of an industrial level language model tool. And I've heard great things about some of these other areas, but it allows us to do tokenization and part of speech tagging really quickly. We also use GenSim, which is a topic modeling tool, and we put that on TensorFlow, and that's exactly the stack that I'm going to be showing you, the sort of embeddings work that we've been doing today. I've heard great things about Amazon SageMaker on distributed systems, so it really does depend on what your context is for which one of these requirements is going to be helpful in your stack. So, if you're a Java developer, the OpenNLP library or the SyntaxNet might be more helpful for you. But as a Python ecosystem person, Spacey was great. So the first thing that we did was train a language embedding model on Korea language. And so we took a whole lot of job descriptions and trained it and tried to look for which ones were doing best. And we have a set of external tools, and that's actually almost its own talk in terms of how you evaluate these embeddings. And so you get this 2D projection, which is really nice, from TensorFlow and various others. And so we looked at some of the clusters that we saw. So you could see there's a cluster up there, and what we saw here was that equal opportunity in PERC language tended to correlate, equal opportunity language tended to sort of come out together, which was cool. And PERC's language also sort of got pulled out of that area. And that's actually really interesting to me, that they are so far apart, because usually if you look at a job description, it's PERCs and then you talk about equal opportunity language. And somehow this model has been able to figure out that these are two distinct things and they're not right next to each other and they're not mixed up. So that was, that gave us a lot of faith in this. What was also interesting was a couple of other clusters that we saw. This is actually sort of what we thought is sort of soft skill language. It's sort of separated it there, which I think is really interesting. So talking about communication skills and prioritization and problem solving skills. And then we saw language around requirements. So the minimum number of required years also to come up separately to that. And you can see these are sort of close together in this projection at least, which I think is sort of interesting. But so I've shown you here that this model does a really good job of, in an unsupervised way, trying to extract important information from job descriptions. But the question that I asked at the start of this is, how have data science skills changed over time? So I haven't actually even talked to you about time yet. And there's two ways of doing this using embeddings. The first is to use static embeddings. And so essentially that one model that I trained one for 2015, one for 2016, and so on for each year. And then what we do is we sort of stitch them together. And so I might look for the word cat, because I'm assuming cat doesn't change from 2015 to 2018, which is a huge assumption, because maybe cat in 2015 was talking about keyboard cat, and cat in 2018 is more about like cat memes or something else, right? And so it requires a lot of hand stitching, of making a lot of decisions about what we think is important. And also, it's quite data hungry. And so this is a process that requires billions of words at every level of these embeddings. The alternate mechanism, and obviously this is my favorite, is dynamic embeddings. And essentially what it is instead of training one model for every year, we train one model overall. And one of the features that's associated with them is the year. And this is very interesting. This is, firstly, it's very data efficient, which I'm going to talk a bit about later, and it doesn't require alignment. And the one benefit is, say, like my server went down and I lost half of my records for 2016, which hasn't happened, but if it did, it can take the information from the 2015 and 2017 and try and infer some idea about like where 2016 should be in the middle of that. And that's actually very helpful when you have sort of very imbalanced data sets. It has a mechanism of dealing with this. So there are three sort of implementations of this dynamic embeddings. The one that I'm going to be talking about today is by Maya Rudolph and David Blair. And that was for the very simple reason that they actually made their code public through their GitHub profile. So that's their repo link. And they also had two other really beautiful things that they made it really easy to use. So even if you're not like an embeddings expert, even if you're not excited about language modeling, I would recommend you give this a go, just because there's two very easy ways to get really interesting outputs and to get a lot of information out of it quickly. The first is, one of the outputs after you train your embedding model is this absolute drift. And this is basically just a list of the words that have changed the most in that period of time. So you can actually go from getting your, like as in throwing all your documents into this embedding and then getting the most important terms very quickly. And so in this case, they were used, this is an example from their paper where they used the Senate speeches. And you can see that, you know, words like Iraq have changed the most over time from the 1880s to now. So it went from talking about, you know, various empires and things like that to talking about terrorism and that sort of side of things. And so it does identify top words that have changed over time. And the second area that is of the output is that it tells us what are the nearest neighbors of the most drifting words. And so this is an example of unemployment where you can see that it sort of has a moral twinge in the first half of, in the 1860s and the 1940s, and we were talking about deplorable and things like that, distressing and destitution, and then it becomes an economic term in the 2000s at that point. And so it gives us a clue into what we think is shifting over time. So let's talk about our experiments that we did. And so I did this actually with all job types, and this is something I'm happy to talk a little bit about later, but we had a couple of theories, and there are a bunch of reasons why we did it that way. We had one set of experiments with a small corpus, and so that was with 50,000 documents. And so what we're talking about is about 16,000 jobs per year. We did very minimal data pre-processing. The reason why I love this model is that there's not a lot of, you don't have to get too involved in making a lot of deep data pre-processing steps. The large corpus that we did was 10 times that size, and we wanted to see what are the differences between these. So can we get useful insights out of the small corpus? Because that's actually a really important question in especially this embeddings work, is that, you know, we need such huge amounts of data and information. And actually we did. So this is just the small corpus examples. So again, the top words that came out of this analysis, one of them was PhD, one of them was MBA. And I was actually really excited about that because I wanted to know, you know, are the requirements for these going up or down? You can't tell from the drifting analysis. And what we saw was that PhDs and MBAs across all jobs, the requirements of that in 2018, at the end of 2018, have actually reduced quite significantly. And what's interesting is in data science jobs specifically, when we look at PhDs, people don't ask for MBAs in data science jobs for the most part. They've actually gone down. And so that's actually very exciting for people who don't have those sort of skills and background, that the requirements, the huge demand for data science skills is sort of increasing, and, you know, the drop in requirements is happening. So the next sort of set of questions is other sort of skills that we saw. So everything that's in blue is something that came out of the actual top drifting words analysis, and the pink and the gray boxes are things that I threw in as controls, because I'm still a scientist at the end of it, and, you know, when something's too good to be true, I sort of want to like push the bullets and test the frontiers of that sort of thing. So Tableau actually came out of our analysis, which I think was very interesting. So data viz skills are up, and so I threw in Power BI to see did we see any difference, and actually Power BI went up, but that but actually our analysis from this embeddings didn't push it up because it was coming off a very small base. And so it's kind of a robust thing. So even though Power BI had gone up, it was there weren't that many jobs that required it to begin with. Hadoop was another area that, another term that came up in this analysis, and Hadoop has become a lot less popular. And so I tried to experiment using Spark. Spark is also, so these are both cloud-based management tools for deploying models or various things to production to cloud. Spark is actually, the difference between Spark and Hadoop is sort of more general purpose versus Spark, which tends to be used for machine learning in general. And so when I saw Hadoop, I thought, okay, well that makes sense because AWS, the cloud infrastructure, have made that really easy for a lot of companies to do a lot of their work on the cloud. But Spark, on the other hand, is something that still is very unique and very specific, and so they haven't really hit that market. And so I'm not surprised to see that Spark didn't change, but Hadoop did. And then the last is in terms of scripting languages. So Perl came up out of our analysis, and that is not surprising. How many of you are familiar with Perl? Yeah, so there's a good number of you. So Perl is one of the scripting languages that was actually the original in terms of natural language processing because it's very good at dealing with strings. And Python, the Python ecosystem has kind of come over and taken over that in some ways by building a lot of libraries that allow us to do these sorts of things. And Perl is still asked for in job descriptions, but usually in combination with various other scripting languages. So usually it's a company that wants a scripting language, not just that. So Perl came up, Python and Java and all of these other sort of scripting languages were reasonably steady. We haven't seen a huge amount of growth or anything else in those. It's just the area that they've gone to has changed. So the last thing that I wanted to talk about was the large corpus. And so we got a lot of information from 16,000 jobs a year, which I thought was really interesting. When we scaled that up to 500,000, what we found was that actually the top term that came up, I was super excited, was SQL. And I had assumed for a long time that SQL was actually going to be really important in this process. Like I've seen it all over the place in terms of job descriptions because my job is to look at job descriptions all the time. But we didn't see any change in SQL demand across the board in data science jobs, in all jobs. There's no huge difference, in fact, over the years. But what we did see, though, is I thought about it and I thought, well, actually, this thing picks up subtle changes. And so let's go back and take a look at very specific types of roles. And so we did that, and that's where we saw the huge change in SQL. And this is a nice and beautiful thing about this model. So, you know, in finance, FP&A roles, so these are finance and accounting roles, we saw a huge increase in the number of SQL, in the jobs that require SQL in these roles. In biz dev roles, we're seeing a huge increase. And in my favorite, HR roles, we're seeing a large increase in people analytics and that sort of area. And so what this is telling us is that the traditional areas of demand, that places where we're seeing uptake of data skills are not in core data science roles. And that was sort of my hypothesis going in, is that we're seeing huge demand of data science skill sets outside of those traditional roles. These are in things like FP&A, in terms of HR, the areas that you don't necessarily assume. These are actually really critical for a lot of companies. These roles are dying for like a lot of analytics. And so one of the things that I tell a lot of people when they come to me for career counseling is to say, figure out, like, get an expertise in these areas, because having those data skills in that makes you a really powerful person in those roles, and you'll always have a job in those areas. Having that domain expertise of HR, for example, with a analytics background means that you're always going to have a job, versus the sort of data science teams that we have that sort of flit around from time to time that don't develop expertise in a data science skill set, and they don't, well, so they might have data science skill set expertise, but no domain expertise or associated with that data. And so I think this is sort of very interesting for someone, especially our data analyst who was looking for jobs, is that one of the areas that they should be looking at are those unconventional roles within companies that are actually really stalwarts of those. And so what have I talked to you today? I've talked about how static embeddings have got corpus issues, and those are things to be wary of when you're building those corpuses and you're developing those models, and some considerations that we had for custom embedding models in terms of how to train them and develop them. And lastly, I talked about this dynamic model that I think is really powerful because you can do a lot with a very small amount of data and get a lot of insights from it without needing to sort of go into the depths of language modeling, but you can also do that if you want to. And so I just wanted to thank you all for listening to me, and if anyone has any questions, I'm available both on Twitter and on LinkedIn if you want, and the slides are here, and I think we have to, I may have just taken over my entire time talking, but feel free to come up to me afterwards. I'd love to chat.